In this video, we're going to work on this web app you see right here called the Waitlist app, which is mostly functional, except for one big missing feature, but I'll get to the missing feature in just a moment here. So you might be wondering, what's this waitlist application for? Well, one example of where this app could be used is in a restaurant, where you need to place walk-in customers on a waitlist so you can serve them on a first-come, first-served basis. Now, one of the interesting things about this app is that this page we're looking at, the waitlist page, updates itself in real time. So what exactly do I mean by real-time updates? Well, let me show you. I'm going to open up two separate browser windows with two different signed-in users, and I want you to watch what happens when I add a name and a party size in one of the windows, and then I click the Save button. Okay, so basically, the new party was added in both windows in real time, and additionally, if I click either the Seat or Cancel buttons, the party is removed from the list in every browser that has this page open. Let me ask you a slightly tangential question. How many programming languages do you think I had to use to create this real-time waitlist page? I bet a lot of you guessed two languages, obviously Elixir and probably JavaScript. This would be a reasonable guess, but it's wrong. The only language I used to create this real-time page is Elixir. Okay, so how is this possible? Don't you need JavaScript or some other front-end language to make rich real-time web apps? Well, no. I didn't need to use JavaScript because I'm using the relatively new Phoenix LiveView library, which allows you to build rich real-time user experiences, but with a greatly simplified programming model using only server-side Elixir. And by the way, if you'd like to learn more about Phoenix LiveView, you can check out my intro video that I created on it, which is linked to on this page. Now there's one other part to this app, which is the list of users that you see here. This users page is just a conventional server-rendered page, and really there's only two things you can do on this user page. You can see all the registered users, and you can edit a user if needed. Now obviously, this app already has user authentication set up, and given the fact that we're looking at users, and you can see a signed-in user here, and you can see a sign-out link here, and here's the interesting thing about authentication in this app. It only took me about 2 or 3 minutes to set up because I'm using the excellent POW authentication library. You can learn more about the POW authentication library from my video on POW that's also linked to on this page. Okay, now that you've got a basic sense of what this simple app does, I want to circle back to something I mentioned a moment ago, which is that there's a big missing feature in this app. So what's missing? Well, you can probably guess based on the title for this video. It's missing proper authorization features. So what do I mean by authorization? Well, let's take a quick look at authorization and a related topic, authentication. Let's start with a working definition of what these two terms mean. Authentication refers to the process of proving you are who you say you are. So for example, the most common way of authenticating a user is by having them enter a unique identifier, like an email address, and then proving that they are this identity by entering a secret password. Now, authorization is separate but related to authentication. Here's what I mean. Whereas authentication is a process that proves you are who you say you are, authorization defines what you're allowed to do. In fact, you could say authorization is a combination of identification plus permissions. Okay, so let's consider authorization in the context of this waitlist app. Imagine we're using this waitlist app in a typical restaurant, and there are basically 4 types of users for this app. One of the users we'll call a kiosk user. In other words, it's an account you could use if you had a self-serve kiosk where customers could add their own name to the waitlist. Now keep in mind, this kiosk user should have very limited permissions in this app. In other words, they should be able to add their name to this list, but they shouldn't be able to click the Seat or Cancel buttons, and they definitely shouldn't be able to do anything related to users. The next type of user could be a host or hostess, which can both add customers to the waitlist, and they can either seat or cancel a waiting list party, but they shouldn't be able to view or edit users. The next type of user might be a server, which can only view the waitlist, and they can do nothing with users. Now the last type of user might be a manager, who should be able to do pretty much everything in this app. So the problem with this app is that currently, every user can do everything in this app, which isn't good, but we're going to fix that in this video. Okay, so how do we fix this security-related problem? In other words, how do we limit each of these users to only performing certain actions in this application? Well, imagine we've got these 4 users shown here, and we've got these permissions here that can be applied to users and parties. So how do we set up each user with only the appropriate permissions? Well, one way of handling this would be to specify a set of permissions on a user-by-user basis. So for example, you'd have to somehow pull up an individual user and say they only have permission to do these actions, and you'd have to follow the same process for all 3 users. Okay, this process would be totally doable when there are only 4 users, but what if you had 50 users, or 100 users, or more? Well, that's when this type of authorization scheme starts to become unmanageable, as you can probably imagine. Okay, so what's another option that's hopefully a bit more manageable? Well, the next approach I'd consider is called role-based access control, which I'll briefly explain right now. Role-based access control is similar to the first approach, except it adds a level of indirection between the users and the permissions. This bit of indirection is what's called roles. Now, instead of mapping users to permissions, we'll map roles to permissions. Then we'll assign each user to 1 or more roles. And by the way, this app already has users mapped to 4 roles, as I outlined a moment ago, which you can see right here. So the nice thing about this approach is, when you've got many users, you don't have to map each user to a bunch of permissions. You just have to map the user to an appropriate role, which already has the correct permissions. This is typically an easier way to manage access control. Now, role-based access control is a pretty good option for a few different reasons, such as it's pretty well known as it's been in use for around 3 decades, and it's widely used, and it's relatively simple. However, there are plenty of shortcomings in role-based access control. For example, in scenarios where there are many different users with many permission permutations, you might end up with role explosion, where you've got so many different roles that maintenance and auditing becomes a nightmare. Additionally, sometimes role-based access control is just insufficient. So for example, you might need to limit access based on other attributes, such as time of day, or the user's IP address, and so on. For these types of scenarios, a common security scheme used is called attribute-based access control, which gives you more features, but it adds a lot of complexity. Now, keep in mind, we've briefly looked at 3 different approaches, but there are many other kinds of access control models, as shown here, but let me give you a bit of hard-learned advice on which approaches to consider. I'll let you in on a costly mistake that I've made once or twice. Often when I'm working on a new project, the initial security and authorization requirements are a bit vague and largely undefined. I think this initial vagueness is pretty common in many projects. Now, a couple of times in the past, when I've run into this vagueness related to authorization, I created a solution that could handle every scenario that I could think of. But here's the thing. The vast majority of those scenarios never got used, and all that work turned out to be a big waste of time. So here's a word of advice in the absence of clear direction. Start by designing an authorization system that's as simple as possible, and only add features to that system when it's abundantly clear that the feature is necessary. Actually, that's pretty good general advice as well. Now, in my opinion, implementing a role-based access control system is relatively simple, and often it's completely adequate, and it feels like we're following the 80-20 rule. In other words, implementing role-based access control takes about 20% of the effort of a more sophisticated system, and generally it covers about 80% of the use cases you'll typically need. So in my opinion, role-based access control is a pretty good first choice, and that's what we'll be implementing in this waitlist app. Now, before we get started coding, I want to set some expectations, and then I want to do a bit of planning. This video is designed for programmers who are already familiar with Elixir and Phoenix. So if you're relatively new to these technologies, it might be a bit of a struggle to follow along, and you might be better off learning the basics before continuing with this video. And here's a shameless plug for the newbies. You should check out my course, Elixir and Phoenix for Beginners, which is linked to on this page. Okay, now let's do a bit of planning. So, given my earlier description of the types of users this waitlist app will have, we'll design the system around the 4 roles shown here. Now, there's a couple of things I want to consider next, which is, first, combining users, roles, and permissions into access control rules, and secondly, the applying of these access control rules where appropriate. For this first option here, we could set up some tables and create some admin pages to allow managing the roles and permissions and so on, but this is already going to be a longer video, so in the interest of time, I'd like to keep things as simple as possible, so instead of putting this stuff in the database, we're just going to define these rules in code, which you'll see in just a moment here. Now, the second consideration is how we'll apply these access control rules. In other words, do we apply these rules in controllers, or maybe in the model or context, or maybe somewhere else? All right, so what's the right answer to this question? I mean, where should we apply these access control rules? Well, in my opinion, there isn't a definitive answer to this question. It's a bit of a gray area, and it largely depends on the project. So for example, in a simple app, like the one we're working on, I'm inclined to apply the access control rules in controllers, as it's a relatively simple solution. But if I was working on an app in the healthcare industry, which contains patient information, I might be more inclined to apply these access control rules in the model or context, or maybe even in the database. But these options are almost guaranteed to result in a much more complex solution. So if you go these routes, you'll want to make sure it's truly necessary. Okay, so to summarize the approach we'll be taking in this video, the access control rules will be defined in code at development time, and the application of these access control rules will be applied in controllers when controllers are involved. However, in our app, we've got this live view, which doesn't use a controller, so we'll also need to apply the access control rules in the live view somehow, but I'll cover that later in the video. Now, generally speaking, the next step I'd take would be to look for a library to handle the implementation of our role-based access control, but I'll be honest with you. Authorization is one area where I rarely find a library that feels just right to me. I've looked at several popular authorization libraries in Elixir, but none of them felt like a good fit for me. Now, to be clear, I'm not saying the existing libraries are bad. No, many of them looked quite good. They just didn't closely match what I had in mind. So we're going to write our own simple authorization library, which is actually a pretty good learning exercise. So, given that we're going to implement our own authorization library, let's put a bit of thought into how it should work. And in particular, we'll look at it from a consumer point of view. In other words, we'll answer the question, what should be the public functions or API for our library? Okay, so let's think about how we'll design our authorization API in terms of roles, resources, and actions. Now by roles, I mean things like the kiosk, host, server, and manager roles. And when I say resources, I'm talking about dinner parties or users. And when I say actions, I'm talking about the things that can be done to resources, like maybe CRUD operations, creating, reading, updating, and deleting resources. Okay, so what should the authorization API look like for creating access control rules? To help answer this question, let me give you a concrete example of an access control rule we might want to set up. Let's say we want to set up the kiosk role so that it can create new party records and read parties. Okay, let me rephrase what I just said in rough pseudocode. We want to grant the kiosk role the ability to create a party and read a party. So what should this pseudocode look like in Elixir? Well, first, I'll say we should have a function named grant, which takes a role, so grant the role kiosk, and what's returned from this grant function call is a piece of authorization data, which we'll define in a moment here. Next, I'll pipe the result of grant to a create function, which represents the allowed action, and I'll pass in the resource the action is authorized on, such as the party. Lastly, I'll pipe the return value from the create function to a read function, which again represents the action to allow, and I'll pass in the resource this action is allowed on, which again will be the party. Okay, this code seems pretty decent. Grant the role kiosk the ability to create parties and read parties, and keep in mind, we could continue to pipe to other allowed actions onto the end of this pipeline. All right, we still need to define what type of data is returned from grant and passed into and out of the create and read functions, but let's circle back to the data we'll need in a moment. Next, let's think about how we'll check or apply the access control rules that we set up with this code right here. So here's an example scenario I want to consider. Let's say we need to check if the kiosk role is allowed to view or read parties. Here's what the pseudocode might look like for this scenario. Can the kiosk role read parties? Now let's translate this into Elixir code. All right, I like the readability of this. Can the role kiosk read the party resource? But what should this can function do? Well, I think it should return the access control rules for the role kiosk. So for example, look at our planned API for creating the access control rules. Now, what if we just put this expression here in a can function like this? Yeah, I think this should work okay. Basically, calling the can function will return our access control rule, and then we can check the rule with functions like this read function, which will return a Boolean value indicating if the reads are allowed or not allowed. Okay, I think these are decent example APIs for creating access rules and checking the access rules, but the next thing we need to do is figure out what type of data we should be using with these functions. So here's what I'm thinking in terms of the data type we'll need. Let's say that calling the grant function returns what I'll call an authorization struct with the role field set to the past role. Okay, what else should be in this struct? Well, let's look at this create function call here, which should take the authorization struct as the first parameter and the resource as the second parameter. So for this scenario, I'm thinking the authorization struct could have a create field that's set to a map. Then when the create function is called, we'll add the passed resource as a key to the map, and we'll set its value to true. Similarly, I think the authorization struct should have a read field that's set to a map, and when we call the read function, the passed resource should get added to the read map, and its value should be set to true. Now keep in mind, we can add additional fields to the authorization struct for additional actions, such as updating, deleting resources, and so on. The next thing to think about in our new authorization struct is this expression here. So basically, calling the can function should return an authorization struct like this, which gets passed in the other read function here, which simply looks at this read field to see if there's a party resource, and it'll return this value here. Okay, hopefully this little thought exercise has given you a sense of where we're headed. So let's start coding. I'll start by writing a few tests, which should help solidify how our authorization API should work. So I'll start by creating a new directory under test named waitlist. Then I'll create an authorization test file, and I'll define the authorization test module. Next, I'll import a module named waitlist authorization, which doesn't actually exist yet, but we'll create it in a moment. Now I'll write our first test to see if a role can read a resource, and I'll assert that the following expression should be true. Can the role kiosk read the resource party? But to use the party schema module like this, I need to alias it. Off-screen, I'll write a few other tests, which are pretty similar to this test, except these tests will deal with the create, update, and delete actions. I'm going to do one more thing as well. I'm going to step out this can function, and I'll build a rule just for these tests. So I'll say, grant this role the ability to read parties and create parties. Additionally, I'll modify the import line right here to exclude the can function we'll eventually be writing in this authorization module. Okay, so I'll run our tests, which fail, as expected, because the authorization module doesn't exist, so let's go create it. First, I'll define a struct, which will be this struct we discussed earlier. Next, I'll create a grant function that takes a role, and it returns a new authorization struct with the role field set to the past role, and of course, to use this shorthand, I need to alias this module. Now I'll write this read function, which takes an authorization struct and a resource. Then what I want to do in this function is add this resource to the read field of the authorization struct. So to do this, I'll create a variable named updatedRead, and I'll bind it to the value returned by the following expression. I'll start with the authorization struct, and I'll pipe it to map_get to fetch the read map. Then I'll update the read map by putting the resource in the read map as a new key, and I'll set its value to true. Lastly, I'll update the authorization struct, calling map_put, passing in the authorization struct, and setting the read field to the newly updated read map. Okay, now I'll write a create function, which will be similar to the read function. It'll take an authorization struct and a resource. Then I'll create a variable named updatedCreate, which I'll bind to the result of the following expression. I'll start with the authorization struct, and I'll call map_get to fetch the create map. Then I'll pipe it to a call to map_put to add in the past resource as a new key, and I'll set its value to true. Lastly, I'll call map_put, passing in the authorization struct, and I'll update its create field to the newly updated create map. Take a look at these two functions. These are almost identical functions, except for the field names you see here. Let's refactor these functions to use a helper function. Let me show you what I mean. I'm going to write a private helper function named putAction, which is going to be almost identical to both of these functions. It'll take an authorization struct, an action, and a resource. Then I'll create a variable named updatedAction, which I'll bind to the result of the following expression. I'll start with the authorization struct, which I'll pipe to map_get, and I'll fetch the action. Then I'll pipe the result to a call to map_put, and I'll pass in the key resource and a value of true. Lastly, I'll call map_put, passing in the authorization struct, the action, and the updated action map. Okay, now I can get rid of both of these nearly identical function bodies, and instead, I'll just have each of these functions call the putAction function, passing in the authorization struct, the appropriate action, and the resource. Alright, off-screen I created update and delete functions which are nearly identical to the create and read functions. Now let's create the other read function. So I'll create the readCheck function that returns a Boolean value, and it'll accept an authorization struct and the resource. Then in the body of this function, I'll call map_get, passing in the authorization struct's read map, then the key to look up, the resource, and lastly, a default value of false if this resource isn't in the read map. Off screen, I'll go ahead and add create, update, and delete functions, which are very similar to the read function. Okay, I think we should be able to pass these tests. Let's give it a try. And it worked. All right, I'm not going to write tests for every other scenario because it's kind of repetitive and boring for a video. So let's move on to defining the access control rules for each role in this app. So in our authorization module, I'll create a can function that pattern matches on the role kiosk. Then I'll grant this role the ability to create parties and read parties. And of course, I need to alias the party schema module. Now, off screen, I'll add can function clauses for the server role, the host role, and the manager role. And I added an all function, which you can see used here and implemented here. Okay, I think we're done with the authorization module. Now we just need to go use it. So let's start by using it in the user controller. So let's start in the index function by first creating a role and binding it to the current user's role. Next, I'll import the functions from our waitlist authorization module. Then using an if, I'll say, can the role read users? But to use this shorthand for user, I'll need to alias the waitlist user's user module. So if this is true, then we'll fetch the users and render them. Otherwise, I'll add a flash message of type error that says you aren't authorized. Then I'll redirect them to somewhere. Well, what do you think about this code we just wrote? Is it okay or not okay? I mean, do you like it or not? What's your gut telling you? Personally, I don't really like where this seems to be headed. I mean, we've barely started applying our new access control rules, and it already feels overly verbose and prone to error. Let's undo the code I just wrote, and let's approach this a different way. Instead of adding our authorization code to each action in our controller, let's create a plug module that we can use in this controller. In fact, let's add this new plug to this controller right now by keying plug, followed by the name of our plug, which we'll call authorize, and I'll pass it the resource or schema module name, waitlist, users, user. Now let's go create this authorize plug module. So I'll create an init callback, which just returns the options untouched. Then I'll create the call callback function, which takes a connection struct and the options from here. So let me explain what we're going to do here in the call function. Now keep in mind, we need 3 pieces of data to perform our authorization checks. We need to know the user's role, we need to know the relevant resource, and we need to know the requested action on the resource. Now we can access the role, which is in the connection assigns current user role, and we can access the resource by calling the keyword module's get function, passing in the options and the keyword resource. And lastly, we can access the action by calling the action name function, which I need to import from the Phoenix controller module. Next, I'll call a new function named check, passing in the action, role, and resource. This check function doesn't exist, but I'll create it right now. So first, I'll create a private check function clause, matching on the index action. Then in the body of the function, I'll say, can this past role do what? Okay, which function should we use here? Well, since we're dealing with the index action, it's a read operation. So I'll call the read function with the past resource. Of course, to use these 2 functions, I need to import our authorization module. Off screen, I'll add a few other check function clauses for creating, updating, deleting, and last but not least, I'll add a default check function clause that just returns false. This clause will get called for any action that's not one of these actions. Basically, this last function will deny all other requests by default. Okay, so these check function clauses will all return a Boolean value. So up here in the call function, I'll pipe the Boolean value returned from call check to a new function named maybeContinue, and I'll pass in the connection struct. This maybeContinue function doesn't exist, but let's go create it right now. So if the maybeContinue function is passed a true value as the first parameter, then we'll just return the connection struct, which allows the request to continue on to the appropriate controller action. However, if the maybeContinue function is passed a false value, then I'll take the connection struct and pipe it to put flash. Then I'll say the flash message should be an error message that says, you're not authorized to do that. Next, I'll redirect the user to the page path index action. And lastly, I'll pipe the result to halt to interrupt the request. Now to use routes like this, I need to alias the routes helper module as follows. Okay, I think this should work. Let's give it a try. So I'll sign in as a user with a kiosk role, and I'll try to navigate to users, and as you can see, we couldn't access the list of users as you'd expect. Cool. For good measure, I'll sign out and sign in as a manager, and I'll try and access users, and this time it worked as expected. Okay, the last thing we need to do is apply our authorization code to the waitlist, which again is a Phoenix Live view. The code for our waitlist live view is in waitlist web live. Now, if you're not familiar with Phoenix Live Views, I'd recommend watching my video on live views that's linked to on this page. However, I'll provide a quick overview of the important parts as it relates to what we're working on. If you look at our live view, there's basically 3 user events that can occur: a form save event, a seat event, and a cancel event. Now, if we scroll down a bit in the live view file, you'll notice 3 corresponding handle event function clauses: one for save events, one for seat events, and one for cancel events. So what we need to do is add our access control code to these 3 callback functions as appropriate. I'll start by importing the authorization module. Then in the save event handler, I'll create a role variable and bind it to the value in socket assigns current user role. Then in this with expression, I'll add our authorization check as the first match clause by saying, can this role create parties? And I'll match on the return value, saying it should be true. Now, if the return value of this expression isn't true, then flow jumps to the else block, where I'll match on the value false, and I'll return a tuple with the no reply atom, and I'll put a message on the socket of type error, which says you're not authorized to do this. Next, I'll do a similar thing in the seat event handler, adding a role variable and binding it to the current user role. Then I'll say, can the role update parties? And I'll match the return value on true, and if it doesn't return true, I'll add a false clause in the else block, which returns a tuple with the no reply atom, and I'll put a message on the socket that says, you're not authorized to seed parties. And lastly, I'll do pretty much the same thing in the cancel event handler. I think that should do it. Let's try it on the browser. So I'll navigate to the waitlist with a kiosk user, and I'll attempt to add a party, and it worked. Now I'll try and seed a party, and that didn't work, as you'd expect, nor does canceling a party. However, if I sign out and sign in as a manager, I am able to seed and cancel parties. Okay, if you want to look through the code in this video, you'll find the Git repo listed below. Hey, if you liked this video, please subscribe, and if you're somewhat new to Elixir and Phoenix, and you'd like to learn more, check out my course, Elixir and Phoenix for Beginners. Thanks for watching, and I'll see you next time.